Good morning, guys. Today we're going to be looking at Giroux control structures. And control structures are used to move our Giroux or perform an action multiple times as long as a condition is true or false. Okay, so let's look at this statement right here. It says, while Bob has a television on, Bob watches. So if we look at that in code, and what it would look like in a code setting, we have while, and then within parentheses we have Bob dot has television, and in another set of parentheses on. So as long as, the way we read this, what it means is when the state of a television is on, then Bob is going to be watching. When the television is no longer on, then Bob will no longer watch. Okay, so the while is the control structure. That is what is determining what we're doing. Okay, has television is a Boolean expression, and a Boolean expression is something that evaluates to either true, false, yes, no, 0, 1. When we get into Java, we'll learn more about Booleans, but in Giroux, it's a true or false statement. Okay, on is the parameter part of the Boolean. Okay, so if something is either on or off. Okay, watches is the action that Bob is going to take. All right, so let's look at our code down here. We're going to create this island, which is a row of flowers at the top row, and then we are going to copy this code and paste it into our Giroux. So if we come over here, we have our code already in, and we have our row of flowers. So I'm going to put this on 5 so that we can go through and see it run. So when I click on Run Program Continuously, Bob will continue to hop across the screen as long as there is a flower ahead of him. So I'm going to slow it down just a little bit so we can kind of see what is happening here. So I'm going to put it on 2, and I am going to run it continuously, and I want you to watch the blue. So it says while is, or Bob dot is flower ahead, Bob will hop. So as we look at it, Bob's looking to see if there's a flower ahead of him. If yes, there's a flower, and this valuation is true, then he'll hop. When it gets to the end of the row, there's no longer a flower ahead of him, so he no longer will hop, and the program ends. All right, so let's do some experimenting. So now we're going to change this to 1, 0. So we're going to come over here, and we're going to change our location to 1, 0. And I'm going to run it on, let's put it back on 5, and run it continuously. And nothing happened because is flower ahead is no longer true. It's false. It skips over the hopping, and then the program ends. So we're going to come back over here, and we're going to change this back to 0, 0. And then we're going to look, and it says, is flower ahead is a Boolean expression that the computer can decide whether it's true or false. This type of expression, or Boolean, was created by George Boole. He's a famous mathematician from the late 1800s who wrote books on logic, computer, mathematics, electronics, etc. Okay, so everything uses the Boolean topics extensively. Now, the parameters for our Booleans, or our control structures, are going to be ahead, left, right, and here. Okay, you choose the one that's going to work best for you in the current situation. So we're going to try this. We're going to start Bob at 1, 0 again, and this time we're going to say is flower left, and we're going to see what happens. As long as there is a flower to the left of Bob, what will he do? So we're going to change this to left. I'm going to rerun this, and I'm going to run it on 5, and he goes all the way across, and then he jumps into the water, and that's a logic error, and we don't want that to happen. That means there's a problem with our program because he can't jump into the water. So is flower left is not going to work with us. Can you kind of figure out something that would work? Okay, I'm letting you think about it. Is there something else that we could use where if we started at 1, 0, we could try? Let's look. All right, so let's change. If we changed it to right, nothing's going to happen, just like we saw with changing the flower one. But we have some more methods. We have is flower, we have is net, is water, is clear. So let's see if we change this control structure to one of these other control structures. And I know that was a trick question a second ago, asking y'all if you knew of a different way of changing this. So we're going to change this to is clear. Got to make sure that you turn your caps lock off when you're trying to do this. And we're going to say is clear. Put my caps lock back on, and I'm going to type in ahead. So as long as it's clear ahead of him, will he keep going? So we're going to run the program continuously, and he's going to keep going. And the minute he gets to where it's not clear anymore, he's going to stop. So if I rewind this and I just randomly stick a net in there and we run this, he's going to stop at the net, because the net is dangerous for Jeru. If Jeru jumps into the net, then he is going to get caught. So here, let's go back and look at our different methods. We have, again, is flower. So is flower looking in the relative direction. Is net looks in the relative direction. Is water is clear. So that's looking to see if there is a flower, a net, a water, clear, ahead, left, right, or clear. Now, there's some other methods that we can use at another time. There is Jeru, and that's looking to see if there is a Jeru in the relative direction. So is there a Jeru ahead? If there's a Jeru ahead of them, of course, they're not going to want to hop into that field, because you can't have two Jerus in the same field. Is facing, is he facing north, south, east, or west? Has flower, meaning does he have a flower in his patch, or pouch? If he has a flower in his pouch, could he throw that flower to break a net so that he could continue on and move? So those are our methods and our relative directions that would go with them.